In this chapter, we're going to explore some trigonometry. So let's start out by exploring some of the graphs of our trigonometric functions, specifically in this video, sine and cosine. So before we start graphing, let's take a look at the circle we have down here. And it has a lot of material on it. And we call this the unit circle. And the reason for that is because the radius is 1 unit. You can be 1 meter, 1 kilometer, 1 centimeter, 1 foot, 1 unit basically. So we have a lot of angles listed on this circle, including the angles in degrees and the angles in radians. Along with that, for each angle measure, we have the coordinate of the intersection with the unit circle. So first of all, what is sine and what is cosine? Now, sine is of a right angle, as you might recall, is the opposite over the hypotenuse. So if we draw a right angle triangle right here on this unit circle at 30 degrees or pi over 6 radians, we see that if we imitate this triangle I have drawn up here, we have x, y, and 1. Because the radius of the unit circle is 1. And actually this should be y, and this should be x. My mistake. I'll use a different color here. Y, x, and 1. So x would be the x value, y would be the y value, and then the hypotenuse would be 1. So sine is opposite over hypotenuse. Well, if the hypotenuse is 1, then it would be y over 1, which is the same thing as y. And similarly for cosine, it would be x over 1, because it's adjacent over hypotenuse, which is the same thing as x. So on the unit circle, the coordinate tells us the sine and cosine value for that particular angle. So we can use this unit circle when we're graphing sine and cosine on a coordinate plane. So what is the trend of a sine graph? Now, a sine graph is cyclic, or it's periodic, which means that it's a pattern that repeats over and over and over again. And the reason for that is because we have a circle. And as we go around and round and round on this circle, we keep meeting the same x and y values as we go around. So if we go around once, we meet different x and y values. But then if we go around a second time, we go through the same x and y coordinates that we went through the first time, because it's a circle. It's the same circle. We keep going around and around and around. So because of that, one rotation of this circle is called a period, or the non-repeating portion of the graph. So for both sine and cosine, we're going to graph one period and look at the trend. So let's look at sine first. So again, sine is the y value of the unit circle. So we see that as we go up the circle, the value increases from 0 all the way to 1, decreases back down to 0, decreases even further and goes negative all the way to -1, and then increases back again to come back to 0, and the cycle continues. So we initially have the trend of 0, maximum of 1, back to 0, the minimum of -1, and then back to 0. This would be the sine trend. So now to make it more easy on ourselves, we're only going to graph 4 critical points. And the 4 critical points are going to be 0, pi over 2 or 90 degrees, pi or 180 degrees, and 3 pi over 2 or 270 degrees, and then back to 2 pi, which is again 360 degrees. So let's label our x and y axes on our graph. So we're going to have pi over 2, pi, 3 pi over 2, and 2 pi. And the reason why we picked these 4 points specifically out of all the points on the unit circle is because all of these are easy numeric integer values. Now, for example, if you look at 45 degrees or pi over 4 radians, we see that they have roots in them, and to estimate that, it's just easier on ourselves to graph the quadrantal angles, which are 90 degrees, 180 degrees, 270, and 360 degrees, the ones that lie on the axes themselves. So if we graph the points now, and I'll label my y-axis as well, we have 0, 0. So this the x-axis is going to be the angle, and the y-axis is going to be sine. So for 0 radians or 0 degrees, we have 0. So it starts out in the origin. For 90 degrees or pi over 2 radians, we have 1. For pi, we have 0. For 3 pi over 2, we have -1. And then back to 0. And we see that trend, 0, max, 0, min, 0. So now if we connect this using a smooth curve, we get the one period of y equals sine of x, the non-repeating portion of the graph. Now let's look at cosine on the unit circle. So remember, cosine is going to be the x values. So we're going to start out with the maximum, decrease down to the 0, decrease even further to the minimum of -1, increase, increase, increase to 0, and then increase even further to come back to 1. So basically we have max, 0, min, 0, max. And this would be cosine. So that is the trend we have. So now if we graph it, we're going to use the same 4 points that we used before. 0, pi over 2, pi, 3 pi over 2, and 2 pi. And the same y values, which is 1, 2, -1, -2. And again, the x-axis is going to be the angle. The y-axis is going to be cosine. Now, instead of 0, 0, we're going to start at 0, 1 because we started our maximum, remember. We go back to 0. We go to our minimum of -1, back to 0, and finally to our maximum again, which is 1. So now if we connect this using a smooth curve, we get y equals cosine of x, one period of y equals cosine of x, the non-repeating portion of the graph. Now you might look at both of these and say, hey, they look pretty similar. Well, that is true because y equals sine of x is a transformation of y equals cosine of x, or vice versa. Basically, if you shift y equals sine of x horizontally, we will get y equals cosine of x, and vice versa. And we'll look at more transformations of both these graphs in the next video. So this is the video on how to graph them specifically. Hope you learned something.